Week 21. Last week, I actually did manage to finish the implementation of Revenue Cat. So now when a user taps on the subscription tile in the navigation panel, the paywall pulls up correctly. So I'm pretty happy about that. It took me, 3 weeks to actually get it done? In addition to that, last week I also did a lot of tooling improvements, and specifically around AI coding agents and the coding editors and the models. And to sort of understand why I did that and why it was necessary, it's important for me to talk a little bit about sort of the current state of AI assisted programming, as well as the tools around it and their limitations, and more importantly, how to get around those limitations. So the tool I'm currently using is called Cursor. It's just an IDE, integrated development environment, sitting on top of Visual Studio Code. To the right of it, there's a little window that you can sort of talk to the AI agents. And then, you can ask the AI agents to do certain things for you, implement a certain feature, do refactoring, write tests, and stuff like that. It's important to know that Cursor itself is not the driver. Cursor is just a car, infrastructure, if you will. The actual brain that does the operation, that writes your code for you, is the AI model. And with AI models, you probably have heard names like ChatGPT, O4, O3, Gemini is a very hot recent one. Claude is another one. And these models are the brains that get installed, or sort of they interact with Cursor. When you ask a question in Cursor, Cursor sends that request as well as the context to the AI agent, to the AI brain, and the AI brain then tells Cursor what it needs to do. Oh, create a file here, edit this file here, and remove this file there. So with this in mind, it works well a lot of the time. It works surprisingly well a lot of the time. It can drastically speed up your programming pace. And, if you don't like writing tests, it can write tests for you. If you don't want to go through all the different pages of documentation to implement a certain feature, it can do that. Problem, though, is AI models like Claude, like ChatGPT, O4, O3, and Gemini, these models, they're trained based on a certain set of data. And when a model gets released, their training data gets frozen in place in the brain. It's sort of like a person who is really good at doing a lot of things and is very knowledgeable about everything that the person is trained on, went to school for, if you will. But the person, as soon as the person goes into the job market, the person learns nothing, literally zero. So, for instance, the Claude model that I'm currently using has a cutoff of January 2025. So any new stuff that came after January 2025, it doesn't have a clue about. And practically speaking, it's actually a couple months before that, because for the data to be good enough to be fed into a model to be trained to begin with, they probably needed to do a lot of processing. So, typically people like to put a 3 months to 6 months backdate for the information that the AI model is actually current on. Now, this probably isn't a big deal if you were to ask it, historical questions. What happened during 1776? One of the fateful days. It can probably respond to that quite well, because that information has been set in stone for a long time. However, if you're trying to get your AI agents to code for you, to write programs for you, and specifically in sort of the cutting edge technology stack, I'm using Kotlin multi-platform, I'm using Revenue Cat, I'm using Compose multi-platform. These things change dramatically in 3 months, let alone, a year or two, right? When you want the agent to write programs using these technologies, it's crucial for them to use the latest information. Otherwise, your code might not compile, things might break. It just gets very frustrating when you try to deal with that. And I dealt a lot of that at the beginning of the sort of the AI-assisted coding journey I embarked on. And this supposedly automated process became more and more manual. In other words, the agent cursor would actually put in the stuff roughly in place for you. But there would be a lot of compilation issues because it might be importing a package that no longer exists. It might be importing some functions that have moved to a different place. So you're going to have to go into your IDE and fix a lot of those issues. And if you ask the AI agent to fix those problems itself, it would actually get stuck in the loop because it doesn't know any better, right? The information that it has is outdated. So to fix this problem, you need to give the AI agent, the brain, the newest information. And there are many ways of doing this. And the easiest, sort of the lowest barrier of entry version or method that you can do is just by copying and pasting some documentation into the chat prompt so that the AI agent is aware of it. It becomes a part of the context. And then sort of it will incorporate that when it's trying to give you the response. This works in limited circumstances. If you're only looking to implement a small function, if your scope is extremely limited, and you can find really readily available, copyable, and pastable information, this works. But if you're working on like a non-trivial project where you have to deal with hundreds of different functions and different best practices and all of those things, it's not very practical for you to find all the information. And every time when you ask the coding agent to do something for you and copying and pasting everything into the prompt, right? It's just not going to work. And plus, if you include more context than it needs, you might actually degrade the quality of the response the coding agent can give you. Keep in mind that every AI agent has a context window size limit. So in other words, the maximum amount of information that it can hold from the user before it generates responses. And giving it documentation takes up that amount of information. And every model also has a sweet spot with regards to how much context you give to it before it starts degrading its performance. So in a pinch, the copying and pasting method works, but it's not very practical and it's not very efficient. So the zeitgeist way, the most sort of up-to-date way that you can solve this problem is by using an MCP, model context protocol, I think that's the name of it. Anthropic, the maker of Claude, actually created this. It's an open source standard that anybody can use, and now a lot of the big players are actually adopting it. What it is, it's essentially a standardized way of defining tools that an AI agent can have access to. So Anthropic describes it as the USB-C plug for the tools of AI agents. Now, what does this mean? AI agents, the ones that I've been referring to, they are large language models, right? They're essentially a very large file, a very, very large file, like tens of, not hundreds of gigabytes. And the files themselves don't do anything. They're not executable. So when you push it through a computer, the computer wouldn't know what to do with it. The file itself is just sort of a lot of different relationships. The way to think about this is a lot of numbers in it, but like the way to visualize is a lot of different relationships and linkages between different concepts, things, and ideas and notions. And when you feed some text information to it through its autoregressive function, it can then generate one token at a time. And the way to think about token is like a token is about a word, not necessarily, but a lot of times a token is about a word. And then so it sort of generates a word at a time. And every time it generates a word, it takes that word into it, feeds that word back into it, so the next word can appear. So the magic that you see when you ask ChatGPT questions is literally just a static file, the static of hundreds of gigabytes of file. There's a function sitting on top of it, and then you feed it text, it starts spitting out one word at a time. Sort of like, I suppose it's sort of like a toddler trying to babble and try to talk. That's all that I can do. It can't do anything else. It can't, access files on your computer. It can't pull information from the internet. You have to build tools to feed this babbling baby information for it to spit back out information. All that it does is processing incoming information, spitting out texts back to you. So the problem is then, what if I want to incorporate the latest documentation from another particular source? What can I do? Now, earlier I mentioned that you can just copy and pasting things into the text you feed this model, but that becomes very tiresome. So MCP is a standardized way to define tools that an AI model can get access to. So with MCP, it's sort of like this is a USB-C port if you think about it. It's sort of like the linkage between this brain that only knows how to talk, between the brain and everything else that the brain needs to do. So the brain can, through the MCP, can issue commands. So for instance, instead of saying, oh, user, please go ahead and fetch this information for me, the model can then talk to the MCP directly, and MCP can then go and fetch the information from the internet, fetch some documentation from a computer, and stuff like that. So that's MCP. So what Cursor allows you to do is that you can define MCP tools available for the AI agents that you want to use in your programming session. And that's what I did. So I set up a local vector database where a lot of I embedded the documentation that I grabbed from the internet. So for instance, I'm working on Kotlin multi-platform. There is a repository released by Google of all the possible documentation that you could possibly want from Kotlin multi-platform. You download that repository onto your computer, and then you use OpenAI's backend to embed it. In other words, to turn the text that you download from the documentation into weights, numbers that the AI brain can understand. And then, so the texts get converted through embedding by OpenAI into weights and embeddings. And then you can spin up an MCP server. You can do that locally. That reads the embeddings, the numbers, the weights that you just created via the OpenAI tool. And then the MCP can then feed the information to the AI agent in your cursor. So whenever, for instance, now what happens is when I want to do anything in Cursor, I asked it to, for instance, implement a particular function. What it will do at first is to check MCP for tool call into documentation retrieval. And then the MCP then hands the documentation to the AI model. The AI model can then read, oh, this is the function signature. This is the parameters I need to supply. And then it can go ahead and actually do the implementation. So this setup actually took me a little bit of time. Last week, most of my time was actually spent implementing this. And oh boy, the difference it made was dramatic. The one-shot compilation errors has gone from like almost 100% of the time to maybe 20 to 30% of the time. Okay. And even during those 20 to 30% of the time, the compilation errors are just like a handful, like 2 or 3, as opposed to like a giant list of all the things that the AI models didn't do correctly in terms of using the correct signature. So, and then I employed another trick where in the prompt, you can actually ask the AI agent to build after it's made its changes. And then in Cursor, the AI agent can actually read the terminal output. So if the build fails, then the AI agent can see what's wrong with it and then try to fix it using the latest documentation that you can supply to it via the MCP connection. So this has dramatically sped up my development pace with using AI-assisted coding agents. And it's interesting because I don't know why I never actually thought about implementing this in the first place, but after having started using it, it made me realize how stupid I was for not looking into it. I mean, it's really you invest a little bit of time here, and then you can save a lot of time down the line. And from what I read online now, because again, the whole AI is such in the frontier space that a lot of people are still experimenting themselves. A lot of folks that don't actually do this. And I think that if you haven't tried it, give it a try. Use MCP, use documentation embedding. You're going to be very surprised by how big of a difference it makes, particularly for things that are not like, that are frontier, that are not as commonly used. Like JavaScript, maybe you don't have to worry about it, but like once you start digging into like Kotlin multi-platform, yeah, you probably do. That's it for last week. So last week, tooling improvements around AI coding agents, as well as the actual implementation of Revenue Cat. Next week, we're actually going into the bug squashing and polishing stage. So the app is mostly feature complete. There's some little holes that I need to fill in here and there, but I'm going to bundle all of that into the bug squashing and the polish stage. So I don't really have any acceptance criteria to find for next week, but it would be mostly going through my app, finding out exception handling. I need to improve a lot of exception handling, improve my user interface. Now it looks like a intern project. And then just squash any bugs that I come across before I actually release it in the alpha test group. That's it for this week. I will see you next week.